Hey everybody, so today I just wanted to share another tool with everyone. This is all open source, free. You're welcome to do whatever you want with this. But what this is a Syslog API. So for those of you who may not know what Syslog is, this is a way to log information. It follows a very specific format. We're able to send this information over the network. And it includes components, as you can see over here. So we've got facility codes where we can basically specify different levels, right? Whether it be like user, kernel, security authorization, basically how we want that information categorized. Severity code, so we can just have information, right? Debug information, warnings, errors, and emergencies, etc. Timestamp, it lets us know where it's coming from, and then we can also include additional message tags and content. So we can send these messages across the network and have them logged. We can then look stuff up. We can view these messages and kind of dissect. We can filter by different codes. And review this information. So this is a big part of NIST 800-171, kind of the accountability and auditing section of NIST 800-171. This is a really easy way to implement stuff in your LabVIEW code to satisfy those requirements, so we can see what's going on in your code, when things are going wrong, what is it, and be able to have monitoring tools for stuff like that. So with Syslog, we have both a collector. So I have a little example collector GUI here, and we have a device. So your collector is essentially your server. This is just listening for all incoming connections and is just receiving those messages and then logging them. Your device is, like it sounds like, a device. So this could be physical hardware. It could be your LabVIEW application. It could be anything, right? That's just sending these messages to the collector. The collector is receiving them and logging them. So there are a few different Syslog APIs out there that are available on VIPM. So this one is the first and only that, at least for the time being, that implements TLS. So all the other ones use UDP for sending these messages, which works fine. When you need to encrypt that data, though, you need something like TLS. So those packets can't get sniffed. You can't have some sort of man in the middle intercepting those packets. So this is the first toolkit that actually implements TLS. So I was going to demo this using the TLS functions just so you can see. Basically, I'll just pull up this test code. We've got our syslog start. This starts our server. And then we've got this multi-manage, which is just managing connections, right? So this is our connection manager. If you've ever used my TLS API, this is from the TLS API. So it's just receiving incoming connections. When they come in, it tries to connect to them securely using this certificate and key. If they do not have that certificate and key, it rejects the connection. And if they do, it accepts it. And then anytime a message comes in, we are just logging that. Right now, it's just logging that to a text file. I'm actually working right now on just changing that to use SQLite instead, which will give us way more searchability capabilities in there. This is just buffering the strings for the GUI, and then we've got a stop. So there's really not a lot code-wise going on here. And this abort is poorly written as well. Definitely could have some actual stop mechanism to trigger this. But just for simplicity's sake, that's what we have. And then on the device side, we're just initializing the device. We have this device send and a device close. So really, really simple to use API. And then here we're just generating a random number and checking if it's above some threshold, and if it is, we're sending a message to notify that. So let's run our collector and let's run our device. So you can see our device is getting data, and here we're getting a message anytime we get a value that's over our threshold. You can see over here the severity codes, so switching between error and warning, and the timestamps are updating and what those values are. So really simple way to just use Syslog. And like I said, this is all free, open source. You're welcome to just pull this from my repository. This repository for this video is included in the description below. And yeah, like I said, there are different syslog tools available as well on VIPM. If you find another one you like better, the way they implemented stuff, that's great. But for the moment, this is the only one that uses TLS. So it has, let me show you. So in the Syslog API, there's a device and collector group. In each group, it has both a UDP and a TLS implementation. So if I want to use UDP, I can just use UDP. Works fine. So, sorry, not usually developing on this machine, so I think it's missing a few dependencies. But yeah, basic idea is easy to just send, receive data. In this case, my collector is LabVIEW and my device is LabVIEW. That doesn't have to be the case. Your collector could be enterprise level software, and your device could be LabVIEW, or vice versa, right? You could have different hardware or different components all reaching out to a LabVIEW collector, whatever it is. But there are implementations for both UDP and TCP for both devices and collectors. So if this is helpful, feel free to do what you want with it. Like I said, just download, pull the code, whatever you want, and you can do what you want. Hopefully that was helpful for someone. Thank you. Bye.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.